Hello everyone, welcome to this channel. So we are starting a lecture series on AS and A-level maths. First of all, we'll cover paper number 1. We are starting with chapter number 1, which is quadratics. Let's cover some basics of quadratics. First of all, variable. What is a variable? Normally in maths, what we do is we take x, y, z, a, b, c, these alphabets as variables. What do we mean by variable? Whenever we are not sure what the value, a particular value is, we just take a variable in the place of that value. For example, a boy goes to a sports shop and he buys two balls. So for rupees 40 each, and he buys a bat, and he is not sure what the cost of bat is. And at the end, the total bill was, let's say, of 400 rupees. All right. So what we'll do, we are not sure what the value of bat is, so we'll take this value as variable x. Okay. Now we'll start calculation. So two balls, 40 each. It means the cost of balls is 80 plus the cost of bat, which is x, is equal to 400. Now we'll simplify it. We get 400 minus 80, which is, so by the help of choosing a variable, we get to know the value of bat, which is 320. So variable helps us to get along the calculation and solve it. So this is the use of variable. We can choose any variable at any given point of time. So it's not very important to take just x, y, z or a, b, c. There are some variables such as alpha, beta, and gamma. So we can also choose that. Let's move forward. Now, when we have one given variable, there are some cases in which we add these variables. So how the addition of variables work? So let's proceed with x. So if I take x and if I add it with x, so x plus x will give me, so two same things. So for an example, one ball. So second ball. So we'll add them. What we get is two same things. So one variable x, second variable x, and we add them, we get 2x. All right. If we add 2x plus 5x, the things that we are adding are same. They're not different. So we are again taking, for example, two apples. We add with five apples. In total, we get 5 plus 2, which is 7. So 7x. Mathematically, we can also say that we are taking x common, 2 plus 5, which gives us 7x. Okay, this is also good. Now, whatever we are getting over here, we say this to be the coefficient of the variable x. All right. So, for example, if I say 11x, so 11 is the coefficient of x, or I say 13x square. So 13 is the coefficient of x square. All right. So coefficient is basically this constant or this number which is with x. What this coefficient tells us? that how many times is this x being added. So for example, if I say x plus x plus x plus x plus x, so I am adding x 5 times. If I take x common, 1 plus 1 plus 1 plus 1 plus 1, so adding all these, what I will get, this will be equal to 5 times x. Clear? So I hope you are able to understand that what the variable is, what is a coefficient, how to add these, right? Similarly, as we are adding these variables, we'll go for subtraction as well. So addition and subtraction works in same way. So if, but there is one constraint over here, that we need a same variable with the same power. Okay, if the powers are different, they will not be added or subtracted. If the variables are different, they will not be added or subtracted. So for example, if I take 12x minus 3x, variables are same. What this is saying, there are 12 x's are being added and 3 are being subtracted. So it means we'll just work with these coefficients, will not change the variable, or variable will not be affected. So 12 minus of 3 and x, we took x common over here. So what we get is 12 minus 3 is 9x. So this is the result, right? Addition, subtraction works in the same way. No change in the variable, no change in the power of variable or anything. Just the working of coefficients, right? So this is what coefficient is, and coefficient will change in case of addition and subtraction of same variable. I hope it is clear. Let's move forward. Now we get next part is multiplication and division of variables. So if I take x, I'm working with x because it's normally used, but we can take any variable. Working of any variable will be same like x. So x times x, I'm multiplying these two. So what I will get, for an example, if I do 2 times 2, I get 4. I also write it as 2 raised to power 2. So similarly, multiplication, if I am writing x times x, I will write it as x to the power 2. Yeah. Now, if I multiply x with this x raised to power 2 again, what I will get? So, for example, 2 multiplying with 2, what I get? 2 to the power 3. This will give us 8, which I can write it as 2 to the power 3. Similarly, for x, I can write it as x to the power 3. What is happening over here? If we multiply the x's or the variables, we are just changing the power. Okay, whatever I multiply, for example, if I take x, same, the variable should be same. So x to the power a times x to the power b. Okay, this will give us x to the power a plus of b. Okay, two multiplications, powers are being added over here. So x to the power a, x to the power b will give us x to the power a plus b. For example, if I take 9 to the power 3 times 9 to the power 4, this will give us 9 to the power 3 plus 4, which is 7. This will be our result. Or if I talk in terms of variables, y to the power 8 plus, sorry, it's multiplication. So y to the power 8 times y to the power 13. This will be y 8 8 plus 13 multiplication of y's but addition of powers. Okay, this will be 13 plus 8 y to the power 21. Okay, clear? Power tells us how many times a particular variable is getting multiplied. So if I talk about x to the power 4, this can be represented as x times x times x times x. Okay, so how many times a variable is getting multiplied? We'll just add the powers. So this is what the power of variable will act like when we are multiplying it. In case of division, if I say, so multiplication works in this way. This is the basic formula over here. Now if I talk about division, so in case of division, one basic thing we want to know that how the power changes. For example, if I say x to the power 3 divided by x to the power 4, what is happening over here? X times x times x divided by x times x times x times x. These are getting cancelled out. We are left with 1 over x. Okay, this can be written as x to the power -1. Whenever we shift a variable from denominator to numerator or numerator to denominator, we change the power by negative. So that will help us to simplify this as well. This is the normal way of doing it, but we can't do this every time. So it's better to do what? X to the power 3 and shift this x to the power 4 to numerator. And we'll change the power by -4. So x to the power -4. This will leave us by applying again this formula. So we get x to the power 3 plus of -4 will give us x to the power 3 minus 4, which is x to the power -1. Okay, I hope this is clear. Multiplication and division of variables. Now what is power and degree, okay, of a variable? So if I say x to the power 7, this 7 is the power as well as the degree of a variable. Okay, degree is normally used in terms of a longer equation. So for example, if we say x to the power 3 plus x square plus x, so in this case this individual x has power 1, this is power 2, this is power 3, but if I talk about the degree of this particular equation, we say this is the degree, the highest power. All right, now what is a equation? Normally these are very simple terms, but we miss out on these. So if I want to know what is an equation, equation is normally represented by this particular symbol. This symbol tells us that whatever is in the left hand side of the symbol is equal to whatever we are writing on the right hand side. All right, so something in the left hand side equal to something in the right hand side, we call it a equation. Okay, or equality. So if I say 3x square plus 2x plus 1 is equal to 4x square plus 9x plus 7. Okay, so these variables are equal to these some of these this equation, and this is equal to these particular things. All right, now there is one interesting fact over here. Whenever we simplify the equations, we shift things to the right or left hand side, or we want to isolate some terms, in that case we need to keep in mind some things. For example, if I say a plus of b is equal to c plus of d, if I want to find the value of a, okay, what I will do, I need to eliminate this b from this left hand side. Journalized way of doing it is, we say we subtract b from both the sides. So whatever the action, if we are taking some action and if we are taking it in the both sides, we are not changing the equality, right? So what I'm doing is minus of b, c plus d, minus of b, both the equations are same. I subtracted b from the both sides. What is left? A, b gets cancelled out, is equal to c plus d minus b. So it looks like that when we are isolating a, we are taking this b to the other side and changing the sign of the b. Alright, so b was positive over here, we took it to the right hand side and we changed its sign. So a is equal to c plus d minus b. Alright, so if I want to apply this same result on these equations which I wrote earlier, so if I want to simplify it and equate it with 0, so what I will do, I will take everything to the right hand side. So 0 will be equal to 4x square minus 3x square. It was positive over here. Coming to the other side, it becomes negative. Plus 9x minus of 2x plus 7 minus of 1. So what I'm getting is, I can also write it as 4x square minus 3x square. Variables are same, just working in the coefficients. 4 minus 3 is x square. 9x minus 2x, working in the coefficients, variables are same. 9 minus 2 plus 7x, 7 minus 1 plus of 6 is equal to 0. Alright, so this is what we are getting. And one more thing, if let's say we have a negative over here, so if I say 2x minus 3 is equal to 4x minus of 8, right? So when I will isolate this, so 0, when I take everything to the right hand side, I will change sign. 4x, this 2 comes to the right hand side, so this becomes negative 2x. 3 comes to the right hand side, and we, because it is already negative, so negative of negative 3 is positive 3. Negative of negative 3, so we get 4x minus 2x minus 8 plus of 3. So sign of negative changes to positive. All right, what we are getting, we are getting 0 is equal to 4 minus 2, which is 2x, and negative 8 plus 3, which is negative 5. All right, 2x minus 5 is equal to 0. So this is how negative and positive changes. Now we also need to know what happens to multiplication and division. So if I have a over b equal to c over d, now if I want to isolate a, what I need to do over here is a over b, I need to remove this b from here. So what I will do, because this is equality, left hand side is equal to right hand side, I will multiply with b so that it gets cancelled out and I am just left with a. So this same operation I will do on the right hand side, c over d times b. B gets cancelled out. What I am left with is a is equal to c over d times b. Alright. For example, if I take equation such as x plus of 2 over x minus 8 is equal to x plus 7 over x minus 2. Alright. Now what I want to do is, I want to find the value of x plus of 2. What I will do, I will take this to the other side. So x plus of 2 is equal to x plus 7 over x minus 2 times x minus 8. So this looks like b is not getting cancelled out. It looks like that whatever was in denominator moves to the other side and gets in multiplication. Okay, so b was dividing in the left hand side, moves to the right hand side, comes in multiplication. So we shifted this to the other side, we got the value of x plus 2. But if we want to solve this equation, we'll need to simplify this as well, because we can't divide it directly. So to remove this from denominator, what we'll do, we'll multiply with x minus of 2. Over here also we'll multiply it with x minus of 2, multiplying both sides. Equality doesn't changes, so what we get, this gets cancelled out. So it also looks like that whatever was in denominator comes to the other side in multiplication. So x minus 2 getting multiplied with x plus of 2 is equal to x plus of 7 multiplied with x minus of 8. All right, so this is how the denominators are eliminated, or how the division is being treated over here. Similarly, with multiplication, a times b is equal to c times d. We get, if we want to isolate a, we say a is equal to, now we'll divide with b, so times 1 over b times 1 over b. What we get, c times d over b. So whatever was in numerator goes to the other side, comes in denominator. B was in multiplication, in other side, right hand side, it comes in division. All right, I hope this part is clear. Let's move forward. These are some basics. I think you already know this, but we need to revise it before we move forward. All right, now comes polynomial equation. So polynomial equation is a equation of one variable x, and its coefficients a's and the powers. Okay, so if we add all these different variables together, we get a polynomial equation. What do I mean by that? It is a n x to the power n. Journal equation looks like this, plus a n minus 1 x to the power n minus 1 plus a n minus 2 x to the power n minus 2, and so on up till plus of a 2 x to the power 2, a 1 x to the power 1 plus a naught x to the power 0 is equal to 0. So this is known as polynomial, and this equals to 0 is a polynomial equation. So n can be any number, any natural number. So n is a set of natural number and belongs to the number from set of natural numbers. So if I take n as, let's take it as 7. So what my equation will look like, a7 x to the power 7 plus a6 x to the power 6, a5 x to the power 5, a4 x to the power 4, a3 x to the power 3, a2 x to the power 2, a1 x to the power 1 plus a naught is equal to 0. Okay, so now over here, all a7, a6, a5, a4, a3, a2, a1 and a naught, these are coefficients. Okay, all these are coefficients. We have a single variable x, but we have powers of x. So the highest power of x in a polynomial equation is known as degree, as I already told you about this. So degree of this particular polynomial equation is 7. Okay, this is a polynomial equation. We write this polynomial equation. The journal way of writing it is, journal equation is this, which a and an's are the coefficients. X has power n. We are adding all these terms and equating it with 0. N belongs to natural number. Journal example is this. Now we have some particular type of polynomial equations. Mainly because the chapter is quadratics, so we'll study that. If we take n equal to 2, okay, this gives us a quadratic equation. So using this in journal equation, we get a2 x to the power 2 plus a1 x to the power 1 plus a naught is equal to 0. So this is what a quadratic equation looks like. Degree of quadratic equation is 2. We also have cubic equation and linear equation. So if we take n is equal to 1, we get a linear equation which is a1 x to the power 1 plus a naught is equal to 0. This is a linear equation. And if we take n is equal to 3, we get a quadratic equation. A3 x to the power 3 plus a2 x to the power 2 plus a1 plus x to the power 1 plus a naught is equal to 0. So this is what a cubic equation looks like. Okay, so quadratic equation is a polynomial equation whose degree, constraint over here is of degree. Degree means highest power of x. So degree is 2. Some examples are, so if I say x square plus 8x plus 9 is equal to 0, this is a quadratic equation. If I take x square minus 3 is equal to 0, this is also a quadratic equation because constraint is of x square. There is nothing told about x. Or if I say just x square is equal to 0, this is also a quadratic equation. Constraint is just of x square. Or if I say 7x square is equal to 0, that's also a quadratic equation. Alright, let's move forward. Factors. So what are factors? If I say that let's take an example. Let's take a number 30. So what are factors of 30? All those numbers which divide 30 are known as factors of 30. For example, 1, 2 divides 30, 3 divides 30. We have 5 divides 30, 6 divides 30, 10 divides 30, right? And 15 divides 30 and 30 divides 30. Okay, so all these numbers are factors of 30. Similarly, if we talk about any equation, polynomial equation, we need to find the fact. If we need to find the factors of that polynomial equation, we need to know about the particular equation that divide that particular polynomial equation. What do I mean by that? Let's take two linear equations, x plus 1 and x minus 1 and x plus 8 is equal to 0. If I multiply these, so x times x plus of 8 minus 1 times x plus of 8 is equal to 0. X square minus 8, sorry, x square plus 8x minus x minus 8 is equal to 0. What I get is x square minus plus 7x minus 8 is equal to 0. So this quadratic equation can be written as x minus 1 and x plus of 8. So these are two factors of this quadratic equation. Alright? If we divide this quadratic equation, x minus 1, x square minus 7x plus 7x minus of 8. If I divide this, multiplying this with x, I get x square minus of x. Changing the signs, these get cancelled out. 7x plus of x gives us 8x. Now if I multiplied, will bring this term down, negative of 8. If I multiply it with 8, I get 8x minus 8. This again gets cancelled out. Changing the signs and both terms are same. So x minus 1 was a divisor and x plus 8 is the quotient. So these are two factors of this quadratic equation. So it is proved by the long division method as well. So factors in case of polynomial equation are those particular equation, obviously of the same degree or the smaller degree. So they are those equations which when divide with the polynomial equation give us another equation as well. Okay. Now in case of factors of quadratic equation, so how to identify the factors of quadratic equation? This is one thing. So if, as I took the earlier equation which was x square plus 7x minus of 8, I hope this was the equation. Yeah. So I got two factors of this quadratic equation which was x minus of 1 and x plus of 8. Okay. So these are the two factors of quadratic equation. This. Now if I say, now zeros of quadratic equation, now if I want to talk about the zeros of quadratic equation or any polynomial equation, zeros are those particular values. So these are those values of x so these are those particular values of the quadratic equation which when substituted this to this particular polynomial equation gives us a result as 0. Okay, so this is a polynomial equation p of x. We substitute a particular value x over here. Let's take it as x is equal to -1. All right, so if I substitute it over here, what, or let's take it as x is equal to +1. If I substitute this value to this particular equation, if the complete equation becomes 0, then I will say that this value of x is the 0 of this polynomial equation. In this particular case, quadratic equation. So if I substitute x is equal to +1, p of 1, what I will get? Square of 1 plus 7 times 1 minus of 8. This gives us 1 plus 7 minus 8. Yes, 8 minus 8. This is a 0. Right? So how to find these zeros? What we need to do over here is, whenever we say that a times b is equal to 0, it's a normal rule that either a should be equal to 0 or b should be equal to 0 to make the product equal to 0. Either of them should be equal to 0. So we'll take A is equal to 0 or B is equal to 0. Similarly, for finding the zeros of polynomial equation, what we'll do, we'll convert this polynomial equation, the quadratic equation, in terms of its factors, that is x minus 1 and x plus of 8, right? So this was our polynomial equation, x square plus 7x minus of 8, right? And two factors were x minus 1 and x plus of 8. So let's check. So if we are saying this is the zero, we need to find the zeros of this polynomial equation. We'll say that either this particular factor is equal to 0, x minus 1 is equal to 0, or x plus of 8 is equal to 0. Alright, so x is equal to, from here minus 1 goes to the other side, we get 1, and x is equal to negative of 8. So we get these two values of x for which these factors are becoming 0. So if we substitute 1 over here, this particular factor will become 0. If this factor becomes 0, the this particular factor becomes 0 in the polynomial equation as well, and makes the complete equation 0. If this factor becomes 0, it becomes 0 over here in the polynomial equation, makes the complete polynomial equation. So for finding the zeros, the best way is to find the factors and then find the values of x for which that factor is becoming 0. Alright, we also say that these are roots of the polynomial equation, or we also call it solution of the polynomial equation. Okay, so now solving a quadratic equation by factorization method. So we are starting with the chapter now. So we need to solve a quadratic equation. So let's take a quadratic equation as x square plus 12x plus of 20. Okay, this is a quadratic equation. We need to solve it. Solving this equation means we need those values of x for which this quadratic equation q of x becomes 0. All right, first way of doing it is by factorization method. First of all, we need to form factors of this quadratic equation. How many factors do we get? We get factors equal to the degree of the equation, that is 2 factors. X square plus 12x plus of 20. How to form factors of the quadratic equations? This is the middle term. We'll do it by splitting the middle term. We need to split this middle term in such a way that the sum of the two terms that we are forming, two terms, the sum should be 12x. We don't need to change the equation. We are just changing the form of the equation. So the sum should be 12x and the product should be equal to the product of coefficients of first term and the last term. So what do I mean if I write it in a generalized way? Ax square plus bx plus c. So I'll split this b in such a way that the sum should be b and product should be a times c. So if I take a closer look to my equation which I'm solving, so for for x square plus 12x plus 20, sum should be equal to 12 and product should be equal to 20. Now what I will do, I'll start with 20. I will check the factors of 20. 20 has factor 1, so I will check the pair of factors. So 1 and 20, 2 and 10, 4 and 5. But this pair should give a sum of 12. I think there is only one, this one. So I will split this middle term by using 2 and 10. X square plus 2x plus 10x plus 20. I will take these common, um, some I will take things common from first two terms and from last two terms. What I can take common is x from here. I get x plus of 2. I can take common 10 from here. I get x plus of 2 again. So again I will try taking common from these two terms. I think x plus 2 is common. So x plus 2, taking this as common, what we are left with is x plus 10. So I factorized this quadratic equation and I got x plus 2 as one factor and x plus 10 as another factor. So now I can say x plus 2 times x plus of 10 is equal to 0. It means either x plus 2 is equal to 0 or x plus 10 is equal to 0. So x is equal to negative 2 from this particular equation, or x is equal to negative 10 from this particular equation. I get two values of x. And if I need to verify this, I'll check that the polynomial equation p of x, which was x square plus 12x plus 20, if I substitute p of negative 2 over here, square of negative 2 plus 12 times negative 2 plus of 20, I get square of negative 2, which is 4, plus 12 times negative 2. I get negative 24 plus of 20. 24 minus 24, 0. Correct? X is equal to negative 2. X is equal to negative 2 is a 0 of this polynomial equation, and x plus 2 is a factor. I'll check for the second one. So p of x, x square plus 12x plus of 20. I'll check for x is equal to negative 10. Negative 10. Negative 10 square plus 12 times negative 10 plus 20. Square of this is 100 minus 120 plus 20. What I get is 120 minus of 120, which is equal to 0. Correct. So this is also a 0 of this quadratic equation, and x plus 10 is a factor of this quadratic equation. So this is one way of solving quadratic equation by factorization. Alright, so from next lecture we'll start solving each and every question of exercise 1a. Till then, take care, study hard, revise. We'll meet in next lecture.